Welcome to Study Loop.
Okay, this is Chapter 11, Section Problem 64. Benzene has a heat of vaporization of 30.72 kilojoules per mole and a normal boiling point of 80.1 degrees Celsius. At what temperature does benzene boil when the external pressure is 445 torr? Okay, so for this we need the Clausius-Clapeyron equation, which I have written here. Is the natural log of P2 over P1 equals minus HVAP over R times 1 over T2 minus 1 over T1. So what we really need here is we need T2, right? So we're looking for at what temperature does benzene boil when the external pressure is 445 torr, and that's not going to be the normal boiling point, right? Because the standard pressure is 760 torr. So if we rearrange this equation to isolate 1 over T2, we can plug in the numbers required. So that equation looks like 1 over T2 is equal to the natural log of P2 over P1 times R over minus delta HVAP plus 1 over T1. Okay, and again, plugging this into our equation, let's see, P2 is 445, and P1 is typically almost always going to be 760. And then for R, we can use 8.314 joules per mole per K. And when we plug in this 30.7 kilojoule per mole value, we have to convert that first to joules. So when we add that to the 1 over T1, also don't forget to convert your degrees Celsius to Kelvin by adding 273.15. So when you plug that into your calculator and then remember to invert this number to get T2, you should get 336 Kelvin, and you can convert that back into Celsius. And what we'll see is that it's lower, right? So T2 is 62.8 degrees Celsius, and that makes sense because we would expect things to boil at lower temperatures at lower pressures because the vapor pressure is allow for that. So anyway, that's how you solve section problem 64